enough with the eggs and sandwiches and apples and grapefruit. Let's do mole calculations in reference to real elements. So we have been given a quantity of magnesium atoms, 1.25 times 10 to the 23rd atoms of magnesium. I want to know how many moles would be in the sample. So we're given a quantity in atoms, and we want to convert it to moles. Now, get familiar with some of the scientific notation. We're going to be dealing with these ginormous numbers of atoms. 1.25 times 10 to the 23rd atoms. It's crazy large. All right, so here's the major conversion factors that we need. 1 mole of anything is 6.02 times 10 to the 23rd atoms. It could be magnesium, aluminum, it could be fluorine, it could be barium, it could be 1 mole of turkeys. 1 mole of anything is 6.02 times 10 to the 23rd particles. Now here with our particle being an element, magnesium, the little particles that make up elements are called atoms. Awesome, so we've got 1 mole of magnesium equivalent to 6.02 times 10 to the 23rd atoms. Now we can use that in different ways when I start setting up my proportions for a calculation. We can have the 1 mole on top over the 6.02 times 10 to the 23rd, or the opposite. We can have the atoms on top, 6.02 times 10 to the 23rd atoms over 1 mole. It's an equivalent comparison or conversion factor. Now, how do we know which one to set up? Well, here's how I like to run these things. I start with the number I'm given. I've been given 1.25 times 10 to the 23rd, and you must put a unit in. This is atoms. And I mean, we could put magnesium in as well. It's atoms of magnesium. But your numbers need a unit. What is this quantity? Oh, it's a bunch of atoms of magnesium. Then I set up a proportion. Now the unit that I've been given, I don't want. I don't want my final answer to be in atoms. I know how many atoms I have. So the unit that you start with is going to go on the bottom. That's the one that I want to cancel. The unit that you want goes on top. I want my answer to be moles. How many moles? So I put my units in first, and then I can put the numbers on the proportion. And now I can kind of see my relationship. 1 mole of anything is 6.02 times 10 to the 23rd particles. In this case, it's an atom. And so now what gives me no more joy is to then cancel these units on the top and the bottom. Atoms on the top, atoms on the bottom, those will cancel. Awesome. And so now the only unit that I haven't crossed off is the one that I want, moles. I'm ready then to plug this in my calculator. So technically, we would say 1.25 times 10 to the 23rd times 1 divided by 6.02 times 10 to the 23rd. So you multiply across the top and divide by any numbers on the bottom. Now, if you want to take a little shortcut here, if you've got times 10 to the 23rd on the top, and you've got times 10 to the 23rd on the bottom, you can cancel those too. It just makes plugging this in your calculator a little bit more manageable, in that really now all I have to do is say 1.25 times 1 if you want to, but then I'm going to divide by 6.02. Well, that's not so bad, huh? 1.25 divided by 6.02 gives me about 0.2076, blah, blah, blah. And that's exactly the answer then that they got up in here. So it was the same setup, but that's just how I think through it. That's my thought process as I'm showing my work and I'm writing out my proportions. That the unit that I'm given, I want to go on the bottom so that it cancels. The unit that I want goes on top. Okay, now it says evaluate. Does our answer make sense? Yeah, I think it does actually. Because if I think about it, If you had half a mole would be like what, 3.01 times 10 to the 23rd particles? Okay, so yeah, we've got less than that. We've got 1.25 times 10 to the 23rd. Okay, so half a mole, if I divide that in half, a quarter of a mole would be about 1.5-ish times 10 to the 23rd atoms, which is kind of what they're going for here, like about a quarter of a mole. That would be about 1.25. Whoopsies, 1.5. Hello, I can do math. 1.5 times 10 to the 23rd particles. And so then if I look at what I have, oh, I've got just a little bit less. So yeah, this answer makes sense. I'm looking for a little bit less than a quarter of a mole. Awesome, let's try some more. Okay, so 6 and 7. How many moles is 2.17 times 10 to the 23rd representative particles of bromine gas? Okay, well, this is kind of a, I don't know, unfair example. Bromine gas really exists as a molecule of Br2. They should have told you that. I wouldn't have expected you to know that at this point in the game. If you only used Br atoms, you're still going to get the same answer. Watch this. You start with what you have, 2.17 times 10 to the 23rd representative particles. A bromine gas is a molecule. So we'd say molecules of Br2. Then I'm going to set up my proportion so I can switch my units. The unit that I have is going to go on the bottom. I don't want this in molecules anymore. The unit that I want goes on top. How many moles? Moles goes on the top. Once I put my units in, now I can plug in my relationship. 1 mole of anything is 6.02 times 10 to the 23rd particles. This would, again, it would have been the same setup whether you used atoms of just Br or here molecules of Br2. It's 6.02 times 10 to the 23rd particles in 1 mole of anything. It really doesn't matter if it would have been listed as an atom or a molecule. All right, so now for the satisfying part. I can cross off molecules. The unit that I have left is the mole. And if I want to make this just a little bit easier to plug in my calculator, I can cancel the times 10 to the 23rds, as long as they're the same. As long as they're both times 10 to the 23rd, you can cancel them both. So really all I have to plug in my calculator is the 2.17 divided by 6.02. Oh my gosh, my calculator is full of garbage. My calculator has 3, 6, like 10 decimal spots. And so you're probably thinking, so what should I round to, right? So we always round back to the initial given number. And so here in the given, there are 3 figures. We don't have to like take it out of scientific notation because that would be a little crazy. We'd be moving the decimal spot 23 places. So in scientific notation, you just look at how many digits are out in front, and then that's what we should leave in our final answer. So my initial had 3 figures. I should round this to 3. So maybe like 0.360. And then my answer is in moles of Br2. There, how's that? 0.360 moles of bromine molecules. But again, you have the same answer if you just used atoms of Br. Oh, okay, that's not so bad, huh? How about one more? Check out number 7. How many moles is, start with the given number, 2.80 times 10 to the 24th, and you gotta put the unit in there. This is atoms of silicone, Si. So silicone is an element, so its representative particle would just be an atom. All right, so then we set up our proportion. The unit that I have goes on the bottom. I do not want this in atoms. The unit that I want goes on top. How many moles? And check it out. It's the same relationship. 1 mole of anything is 6.02 times 10 to the 23rd particles. So really, it didn't matter that it was bromine or silicone. I set up this calculation exactly the same. All right, so now let's see if we can cancel atoms and atoms. And now in the last couple examples, I had 10 to the 23rd on the top and the bottom, and I could cancel that, which was really awesome. Made my calculation a little bit easier. But did you notice this is 10 to the 24th and 10 to the 23rd? Oh, bummer. Okay, so you have a couple options. Option 1 is just to plug this in your calculator. Now, a few words of wisdom. You maybe haven't had to use a lot of scientific notation on your calculators recently. There is a button that is specifically meant to be used for scientific notation. And so here are the 2 ways that you could plug this in your calculator. Option 1 is to type this in, 2.80, and then there's this little key. It's a second function on my TI 80 whatever. There's this little like EE. That means times 10 to the what? It is specifically meant to be used for scientific notation. So then all you have to do is tell it the exponent. And now sometimes you might see numbers like this on your calculator where you do a big calculation and you see like 2.8 E24. And you're like, what's that E mean? Or EE? Scientific notation. It means times 10 to the 24th. And now technically I'm going to divide. So then I can go divided by, and then I'll plug in 6.02. And then kind of similar, EE, hit that EE second function key, and then you just tell it 23. You don't have to say times 10 to the, that EE key knows that you mean scientific notation. All right, so let's try it. 2.80 EE24 divided by 6.02 times 10 to the 23rd, E23 or EE23. Awesome. So my calculator is telling me, and I'm going to round this to the first 3 digits because the initial data only had 3. So I'm going to say 4.65, and that would be moles of silicone. So try plugging it in your calculator that way using this EE key and see if you get that answer, 4.65. Okay, now here's option 2. Option 2 is for that caret key. Those of you who are in love with the caret key. If you're using the caret key, it's totally fine, but then you need to put these quantities in parentheses. So you can go parentheses 2.80 times 10. Then you can hit the caret key 24, but you must put it in parentheses so that your calculator knows that you mean for this to be one quantity. Then I can go divided by, and then same thing, 6.02 times 10 caret 23, but you got to put it in parentheses. All right, try that and see if you get the 4.65. Here's the last option, option 3. For those of us that are comfortable with scientific notation, you know then that 10 to the 24th is just 1 power of 10 greater than 10 to the 23rd. So without having to like take the decimal spot out 23 and 24 spots, you could also do this. So here's option 1, here's option 2. Yikes, I'll squeeze it in up here. Option 3. You could just move this decimal spot one place, make this 1 power of 10 greater, and then you could go like 28.0 divided by 6.02. Ha! That's kind of nice, huh? That's probably like the easiest and the quickest, but you just kind of have to understand the scientific notation. So any of those 3 options will work, but just definitely something to play with in your calculator so that you know that you are entering scientific notation correctly into your calculator.